RZ, and welcome to the welding bench. We're tasked with a little project today. These are the tap handles, or tap wrenches for Bruce Whitman, and these are pretty heavy. This one's kind of light. These are the actual threaded handles here. So we got to figure out a crate for this. I'm just going to kind of bundle them together, and he actually had me pick something else up for him. It's a little starred indicator. It's a nice little indicator. It's the rear plunger type. So I picked that up for him. And I got room to get that, sneak that in there. I'll have to protect that really well because this is heavy, and if it slides into it, it can crush it. So, but I've got plenty of room to wrap that. So let's figure out what size box we're gonna make here. Yeah, we're looking like maybe 22, actually maybe 23. Yeah, 23 inches is going to be some room for some padding. So our box is going to be 23 inches long. And let's figure out our height and width here. And this stuff measures about 5.5. I'm going to go ahead and blow it all the way out to 6 to give me some room for some packing. And I'm kind of thinking 6 is going to be good here too. So, so 23 by 6 by 6 sounds like nice even numbers. And you know, we'll do a cardboard cutout. We're going to do our flat version like I always show you to do to help with your layout. If you ever helped your little sister do cut out paper dolls, this is the time to put that into practice. Now, some of you guys are going to ask me, why didn't you just make it out of wood? Well, you know what, I don't have any around here, and if I did get some here, I probably wouldn't know what to do with it. So anyways, we already know that our inside dimensions want to be 23, so this is 23, this is 6, and we know our height is 6, so we know this is a 6 by 6 corner notch. This right here is 6 by 6. And that's typical all sides. 6, 6, this is 6, 6, 6, and 23, and 6, and 6. So that's pretty easy to figure out your flat sheet. You know, all you do is take all these three numbers, add them together, that's your width. Take these three numbers, add them together, that's your height. Simple enough. And when it comes time to form it, you know, it helps to draw your isometric of your box. Draw yourself a little ISO just so you can kind of help yourself out with the box. This is the simplest box in the world, so. And then do hidden lines here and here. So that's what we're building there. And let's see, our dimensions are 23 by 6 and 6. So that's 6, this is 6, that's 23. So this is helpful when you get over ready to form it. So we're going to build the box first, and then we're going to fit a lid, probably make it, I don't know, 23 1/8 by 6 with a 1-inch return and screw it in or something. But let's get the box made, and we'll go from there. I'll bring you back when we're ready to do some layouts. So all you're going to do is start off, and I just use Sharpie on sheet metal. It works just dandy. And we know we want to come in 6 by 6. So we just kind of rough it in here. 6 by 6. So we know we want Sharpie there. And 6 by 6. And we know we want Sharpie here. Magnum. It's turned into a real joke around the shop, yeah. For those big sheet metal jobs. Alright, so we got Sharpie in our corners. Let's let that dry. We'll come back and start scraping some lines. Okay, and our Sharpie's dried up, so we can get a good place to put our lines. And we've already got a back set here at 6 inches. So I'm just going to put one little scratch mark across there. here and get myself another one. And we'll scribe another one. Again, and again, and twice more. Now what's going to help you out a lot is what I'm going to do next. A lot of you guys that are getting into the sheet metal, you might be having trouble with your inside corners when they come up. What we're going to do is first we're going to pop them with a center punch here. And if you drag your center punch around, you can feel where those two lines intersect. You can feel the crosshair. So there's some finesse there. The people think we're all gorillas, but we're not. Alright, next thing you're going to do is you're going to drill them. And the minimum size drill is going to be the thickness of the sheet metal. In this case it's 18 gauge. But you know, I'm going to, which is about a 1/16 of an inch. But I'm going to drill an 1/8 inch hole. The bigger the better. We're going to weld the corners anyway. So we're just going to pop through and drill 4 1/8 inch holes. And then we're going to do our corner notches. Yeah, I already turned the camera off, but I drilled the holes. But I just remembered I need to finish scribing my lines. And if you want to pick up an old line that's already there that's maybe not complete, you can take your scribe and just feel your way across, and you can feel it drop right down into that into your old scribe line, and then just bring your square over just till it bumps, and just continue that line. And if you look at your line, it is continuous from there. So I was just going to lay that on you that you can actually feel your scribe lines with your scribe bump and continue your line. So little trick I thought I'd lay on you there. Okay, and after a quick corner notch, I just took a shear gun to it, and I'll show you what a shear gun is. This is a Milwaukee, also known as a pair of double cuts. And the heads that come on the Milwaukees, absolute junk. But thankfully the Ket shear head fits right on there. It just drops on. You can drop on a Ket bearing and the Ket operating head, and it works just dandy. And the way it is we've got two movable jaws, and that center finger is the one that wobbles. There is waste. You get roughly a 1/4 inch of a curl that comes out of the center, so there is a wasted metal. It's not like a uni shear that's got a single cutting blade. This has two cutting surfaces. These can cut left, right, and center. They're a pretty versatile tool. It's a very nice shear gun. The Ket brand of entire tool is nice too, but the bodies are made by Black & Decker, now known as DeWalt. But the old Milwaukee units are pretty good. All right, so we got our corner notches done. Let's get over to the brake and form it real quick. Okay, so here's the brake setup. Our part is 23 by 6 inside. So I got these dies set up at about 22 7/8, so they're just under 23. And that one's 6 on the dot right there. So we've already got the dies set up where we can do anything we want. I don't know if we'll necessarily use both sets, but we've got it set up nonetheless. So let's bring our corner notch part over. And this is barely going to clear. If you look between the nose of the brake die here and the throat of the machine, we've only got 6 inches, and we're going to be bending a 6-inch box. So basically a 6-inch deep box is the limit of this machine. So let's get our first one done here, and it's going to become evident what I'm talking about here real quick. And I've got a stop set for 90 as well, so. Actually, it looks like I'm under it, doesn't it? All right. And here's where it's going to become evident why why we needed the 6-inch. Get this clamped right here. And you see my clearance issue right here? Boom, right there. So 6-inch deep box, absolute limit of this machine. Squeaky. Sometimes you can give yourself just a little bit extra clearance just by pulling it out of the way a little bit. That way you can bump your stop. And thank goodness sheet metal is pliable. Alright, we got one more bend to make. We're going to use our little, probably going to be too close to the camera here. We're going to use our little one right here. Get that one formed. And this one, same thing. We're just going to kind of fold this out a little bit and make sure we don't hit anything. And our die's a little bit wide. Let me switch that die out. Okay, and we're back, and I got you pointed down at the die I'm going to use, and I switched it out from 2 3-inch dies to give me 6, just to a 5-inch die. And we started our bend already, but we're gonna finish it with this one. And we're just gonna pick up our old brake line. Squeak! And finish our bend. This one we're just gonna flare it out just a little bit on the sides, just so we can hit our bump stop. All right. There's a nice looking rain gutter. We can just knock it around on the bench with a rubber hammer and get the corners all lined up. And here's one of my first experiments. This is a number 5 lens welding screen, and we're just going to try it. Just started experimenting with lens shades and camera angles and things like that. So I've already reviewed this, and it doesn't look that good. I'm pointing out I'm about 5 inches away from my actual weld, and we just thought we'd give it a try and see if I can improve on my welding video. I didn't show the whole thing. It just glares the camera and you really can't see what's going on. But here we're just going to do a small tack in the corner just to hold it together. And here I'm going to show you how we're going to just make dots across this whole thing. And the reason we're doing this is we've got 030 wire in the machine. There is a smaller wire where you can run continuous beads, but I didn't feel like changing out the wire in the machine. I would like to remind everyone that I am in an open shop, open windows, open doors, and I am doing this in a well-ventilated area. Don't try to weld galvanized in a closed environment. It will make you sick. The outgases will make you sick. And the number 5 lens, I think it's a little too light. I think we're going to be trying a little bit darker shades. We'll try it in the next video. I'm going to keep experimenting until I get it. box. It's welded on the outside on all four corners. And as an experiment and as a demonstration, you guys don't need to remind me that this is just a shipping container. We're going to go ahead and dress up the outside. A lot of times you want to take and grind this and shape it and bring it to a nice sharp edge and just run one little chamfer down at a 45 just to make a nice outside edge. But if you do that, you're going to break through. And what we're going to do is we're going to back it up. We're going to come inside, and now we've got enough weld on the outside, we can run a continuous bead. So we're going to weld first on the inside and then dress and grind the outsides. And let me get the inside welding done, and then I'll show you the steps to dress an outside corner and doll it up. Okay, and we've got our inside corners completely welded, and we just rinsed it out with water and cleaned it out and scraped all the dingleberries off. Now we're good to dress these outside corners, and you know, because we've got plenty of backup inside, we got plenty of weld inside, we don't really worry about the joint. All we're doing is making the outside joint pretty. Again, I know this is a crate, but this is just a demonstration. We're going to be using two different wheels. We're going to do the main shaping with a hard wheel, a hard disc, very worn out hard disc. And then the final dress will be with a flap wheel. This one is by CGW, which is the camel grinding wheels, CGW, there you go. And that's an Israeli company, and I like the camel products. They're not too bad, not affiliated in any way. So anyways, let's do a rough dress, and then we'll come back with a flap wheel. So there's your outside corner. There's very little weld, even showing at all. And it's got a good polish on it. All it needs is a quick shot of primer. You got plenty of strength on the inside, but your outside is dressed. So that's just a demonstration, not needed for a crate. But I thought you guys might like to see how you dress an outside corner and still keep the strength. All right. Okay, well, we got our base done, and it's welded, and I got it outside. I shot a little paint on the corners and got it outside drying. And I thought I'd start on the lid. And the lid's much the same as the box, and we've decided on our finish size on our box was 23 by 6. So what we're going to do is we're going to make the lid an 1/8 inch bigger. So we're just going to do the same kind of pattern that we did before. And we can actually, on the brake, we can use the same setup. And so what we've got, we've decided on 23 1/8 for a 23 inch box, and we've decided on 6 1/8 for a 6 inch box. So 6 1/8 and 23 1/8. And then our corner notches, we've decided on 1.5 inches for those. So that's an 1.5 inches, 1.5 inches, 1.5 inches, 1.5 inches. So what we come out to when we're, if we add all this together, we got 23 1/8 and then 1.5 inches twice. So that gives us 26 1/8 overall on our shear length. And then 6 1/8 and 1.5 inches twice comes out to 9 1/8. So that's our shear size. It's 26 1/8 by 9 1/8. And in a strange turn of events, I just so happen to have a piece sitting here that's 26 1/8 by 9 1/8. It was out of the scrap pile. It's a piece of powder coated So I'm not going to be welding on it because welding next to powder coat sucks. So we'll leave the powder coat side down. I'll do my layout on this side. We'll fold the edges in the opposite way, so the powder coat side's down, so you don't have to look at it. Because what's going to happen in the brake, the powder coat's going to split wherever we do a brake. I may clean the corners just enough to tack weld the corners, but I don't think I want to get near that powder coat, because if you've ever welded near powder coating, you can relate. All right, so let me get this laid out. It's exactly the same as the other thing. The only difference is we got just a little tiny 1/2 inch return. Our brake setup is identical with the way the brake dies are set up, so nothing changes there. So this is just like making that box. It's just got smaller sides. That's it. All right, we got our piece sheared, corner notched, and we're now going to lay out the bolt pattern. It's easier to do it now while it's still flat. So we're going to we measure in from both sides and develop a center line. And while you're doing it, get your center line and be very accurate left to right, and go ahead and transfer your line over to the opposite side. And then from there we want a concentric pattern running out, and we chose 5 3/8. That puts us 3/4 of an inch in here, which is half of our 1.5 inch return. So we've chosen 5 3/8 center to center on all these. So go off your center surface and measure out as you go, and use this as your absolute measuring point. Less room for errors. You're not going to try to chain it and make room for multiple errors. And what you do is you get your square in here, and then take your steel rule and just bump it right into it, and just move back and forth until you see the number here that you like. And then scribe, get it out to the next one, get it on the number you like, scribe, get all your lines straight across from each other, and you've got a concentric bolt pattern. All right, so that's just another quick tip. I am going to use my new punch to punch these, and in a strange turn of events, I picked this up at the same sale where I got Bruce's tap handles. So I'll bring it back, and I got to get a 3/4 limit line in here and get some center punch marks on it. But I'm going to use my new punch for that. After you've done all your scribe lines and done all your center punch marks, this little the Whitney punch has a little raised kind of like a center punch right on that male die, and that makes it really easy to pick up your center punch marks as long as you can get in there and see what you're doing. But you can just feel it drop right in there, and move along with your holes. And what we're probably going to do is take each one of these holes and offset it another 1/2 hole to kind of create a slot. We're probably going to put some kind of a foam tape or a gasket around it just to keep moisture and stuff from getting in there. So we'll kind of slot those so we can push down on the lid and tighten the screws and crush a gasket. All right, so I'll do that off camera, and then we'll get this thing formed up. Okay, so we went out and got our box from outside that we've got our painted corners, and we're going to give our top a test fit, and we need to transfer these holes over to this so we can get some holes drilled in the box. And it should be a pretty snug fit. I can get it on there without pinching my fingers. And start it all the way around. That's it. So I'm going to go around and scribe all these lines and get them all transferred over to the lower box, and we'll go from there. What I did with the holes, I slotted them. I made 2 punches with the Whitney punch, but that left us with something that looked kind of like a figure 8. So I got in there with a rotary file, a little carbide rotary file, and just kind of rounded them out and made them slotted. So we're going to put a little bit of foam tape around here with all the bolts started, and then squish it down in the foam tape and just tighten everything up so it'll remain sealed. All right. Next up, okay, well, we got our holes transferred. I just stuck the lid on and scribed it, and then came along with a transfer punch, 1/4-inch transfer punch, and transferred all the punch marks in, and then I drilled an 1/8 pilot. And now what I'm going to do is I'm going to open them up, and I'm going to show you my grind for sheet metal. Where's the darn lens? The leading edge is very, very flat. And what this is going to do is it's going to keep it, anyone that's ever drilled sheet metal, you know, a really sharp and a really steep leading edge is going to grab and pull you down. This gives you the opportunity to make a pretty clean hole in sheet metal with that flat edge. This is the same as bronze and brass when you don't want it to catch. So the rules for sheet metal are about the same. Help if I tighten my chuck. Huh? And on the back side, nothing. We're just flat. So this is a really good way to keep you from pulling through sheet metal. Just keep that leading edge as flat as you can. All you get is little flat looking mill type chips. You don't really get those big curls. You don't want them. Again, nothing on the backside. You're not blowing out a bunch, and your bit's not grabbing it and sucking you in. And so my bit's kind of magnetized. Look at that. Cool, huh? So we're just going to go along and get all these holes opened up, and then we're going to come back and put threaded inserts in. Nice and nice. I love it. Look at that. Let's go try something. Here, walk with me. We're going handheld. Okay, metal chips on the end. We're going to turn on our little contraption here. I don't think we're magnetic anymore. Let's go find out. All right, let's find us some metal shavings. A bunch down there. Look at that, nothing. Awesome. Okay, it works. All right, let me get these all drilled, and then we'll come back and I'll show you the nutsert tool. Okay, now we're going to throw in some threaded inserts, and what we're going to use, this is very similar to a giant pop rivet gun. It is made by the same people that do the pop rivets. This is made by Marson. Again, no affiliation. And then these are the threaded inserts, and these work very much like a pop rivet. They just have a threaded interior. And there's various mandrels that you get for these, and a few things you got to know when you're using these. You want a very round hole. Make sure your drill bit is sharpened properly. Those triangular holes, they'll slip. And also, earlier I talked about the grind, how you don't want to blow any material out the back and have a bunch of hangers out the backside, because quite often this is in a cavity or something where you cannot access the backside. And all those little hangers will affect how these nutserts operate. And you want a very tight hole too. You want to have to give it a good wiggle to get it down in the hole. And after it's in and you know you're seated, just give it one squeeze and thread it out. And there you have a threaded insert. And these are 1/4 20. This tool will do 632, 832, 1024, 1032, and then it jumps up to 1/4 20, 5/16, and 3/8, all coarse, no fines. Yeah, good little tool. I use it on doors and things like that where I cannot access the inside and I have to bolt something onto a door, maybe a door latch or a door handle. But I use this on metal doors. But I just thought I'd show you that tool and let you know that it is available. Maybe you've got some thin wall box tubing and you have an element you want to bolt to the side of a piece of square tubing or rectangular tubing, but it's not thick enough to thread. So what do? These come to the rescue. You can't access the inside of the tube. I use them to put casters on carts. You know, if you build some kind of cart out of square tubing, you can use these to mount your wheels down at the bottom. So quick and simple, and it gives you a nice little threaded insert. Very strong too. I don't think I've ever stripped one of these. So as long as you follow the rules, everything works just fine. When you start using bad drill bits and exceeding the material thickness and things like that, that's when you start breaking mandrels and you start having failures. But as long as you follow the rules, everything works really good. Okay, so as long as we're over the top on this box, we got all our nutserts in. We might as well throw a couple chest pulls on it. I had these kicking around in a box. I actually have like 30 of them, so they kind of go on everything. And we're just going to mount it with some 3/16 pop rivets. Alright, well that's pretty much over the top. Nice little chest pull. Get that at the other end. Should have just got an ammo box and sent it to him, huh? Okay, so we've got all of Bruce's stuff in here with plenty of room for extra packing. And our lid fits nicely. And we're going to use a flat blade panhead screw. It's like a button head or a pan head, also known as a stove bolt. I was worried about using Phillips, you know, if they don't have tap handles down in Australia, what are the odds they're going to have Phillips too? So I figured he could open that with maybe a 10-cent piece or something. So these are just going to thread into here all the way around and pinch that top shut. The last thing I'm going to do before I close it up, after I get everything foamed and packed in there with the styrofoam, is I'm just going to put a small seal around here, and that's why the slotted holes are there. It gives me room to squish it down into that. So hope you've enjoyed this this building a box. I mean, I probably could have got an ammo box close to that. That's kind of essentially what I built, huh? All right, guys, thanks for watching.